I'm going to start this off with some tech apologies, which I feel like I'm always making in this, but for some reason, this didn't want to go 1080 anymore. I don't know why. So enjoy the blast from the 90s in terms of screen resolution. The other thing is we are doing audio in this presentation. There will be some technical difficulties with that, so bear with us with that stuff. That being said, welcome back to the U. I'm glad we're in this space. This is our. That's all that we're gonna say about that. For more juicy gossip, find anybody who works at WeWork. And so our agenda today is we just started pizza. We're gonna do some intros. I'm Faris. This is the Salt Lake City Python Meetup group. If you're looking for the Java users group, then feel free to head the wrong way down traffic on I-15 at rush hour.
It is a good meetup, though.
They are legit. UJug is a legit meetup. I'm not disparaging them. I just am disparaging this tech corridor that we decided on as a state. It's just okay. You can tell we're a very formal meetup. That's why I'm wearing this sport jacket. No, we're not. We're Salt Lake City Python. We're an affiliate I guess we're technically an affiliate of Utah Python now. Utah Python is our umbrella 501c3 organization. We help get technology education around the state of Utah. It doesn't have to be Python. We're Utah Python, so we prefer Python, but any kind of tech, we're just trying to get it into the hands of people in Utah. We're trying to make sure that people who work in tech, they have a place to go and talk professionally and unprofessionally, and yeah, that's us. So there are some other groups that are definitely awesome to mention. I like to mention them here. Salt Lake City PyLadies. Anybody from the PyLadies? What? No? Nobody from the PyLadies too? That's just fine. Python at the Point, aka Python South Valley. Any pointers? No?
Does that still happen?
It does. Yes, it does.
Okay.
Python Utah North is still happening. That one's put on by my father. I guess that's nepotism technically, but whatever. No, he decided to start something up in Logan. Somebody else did, and then he took it over when he was learning Python. They'll be having their meetup in 2 weeks on, I think it's that Thursday is when they meet. Girl Develop It. Anybody from Girl Develop It? Girl Develop It's a little bit different. They do any programming language. They're much more workshop focused. Really great resource. PyData, SLC. They're a thing. There's a data engineering group. They don't even bear mentioning. I'm just kidding.
Shout out for that one.
Yeah. So Joe runs that. So.
Yeah. So actually, on the 16th, data engineering we hold every third Wednesday of the month. We rotate between Overstock and Murray, and then Recursion Pharmaceuticals downtown. This month is going to be really cool. How many people have heard of real-time analytics?
With Kafka?
Sure. So nobody. Okay, so anyway, real-time is becoming more and more of a thing, and we have one of the authors of a Apache project called Druid. So he's going to be giving a talk on real-time analytics and this new notion of the data river. How many people have heard of data lakes? Have people heard of data lakes? So this is like the new buzzword you got to put into your vocabulary. The data river, it's a thing. Anyway, come check it out. Data Engineering Meetup, Overstock, 16th.
I must point out that that's like Dylan's two favorite things is
what?
Like
buzzwords.
Is like rivers and data. So
yeah, I'm all for this new change.
Well,
I've been doing it for years, Joe.
I'm sure you have.
We also there's a language agnostic group, the SLC devs, and yeah, we got some websites. I never update them. If you want to update them, go ahead. If you want to make fun of me not updating them, just bring it. I live in your hate.
I think they're in Angular 1 still.
Yeah, they're still in Angular 1.3, not even 1.4.
1994 or something.
Yeah.
So.
There must be a major security breach.
It's hacked.
Oh, it's already been hacked. Like, there's like a Russian bot on it now. I don't know. There's all kinds of stuff. This is a sneak project that I put aside, and I even have a bunch of T-shirts for. But we'll see. That one is coming soon. Other stuff. Sponsors, Pythonistas like you, thank you for making your $5 donation. That does go towards stuff like our raffle prizes. It goes towards our outreach programs. So today's raffle prize is an Adafruit PyBadge. It's our last two that we'll be giving out. Although we will keep this prototype just as the example one for when we're doing CircuitPy tutorials and what have you. These are really neat. This is a little device, and I won't shut up about it. And like Dylan's probably sick of me talking about these, but they're awesome.
They're awesome. No,
They-
I'm not sick yet.
yeah, you basically
Give me a go. I'll talk
write
about it.
something in a file called code.py, and then you copy it to this, and it'll run it. That's it. So it's super easy to teach kids how to code, or anybody. So actually, my partner Lexi, she's more of a database person, but she turned this into a gender reveal app because we're having our first kid. So it was like a whole game you had to play, and then it's a boy. So it was pretty fun. So yeah, there's a bunch of little lights over here, and a little TFT screen. I think it was 150 by 150 pixels. It can play noise too. You have to add a speaker for that, but it does play sound. It has an accelerometer in it, and we are giving away 2 of them to at the end of this meetup. We're also going to be giving out this book that covers MicroPython, which is kind of the primordial version of CircuitPython, but they're kind of double forked right now. You can do stuff with that. And yeah, so thanks to our sponsors, Pythonistas like you. Xmission has been a solid sponsor of our pizza since we moved to the U, essentially, even before then. They're awesome. University of Utah has graciously provided this venue, even at the last minute when we switched. And again, apologies for that. If you want to learn more about that, just ask anybody who works at WeWork. And then, yeah,
Do you think there's anybody actually down at the gateway right now looking for the meetup?
I really hope not.
Yeah.
When you Google this, it shows up as being a boomer, unfortunately.
Oh, really? Google still shows it
Did
as
say cached it wrong. Yeah.
Ah,
So, oh well, they
Well,
go shopping. It's fine.
that at least somebody's going to a WeWork. So. Oh wait, this is recorded. Hi, Adam. So yeah, also Tech Systems. They were the ones who originally sponsored a number of these devices. They sponsored the Halloween. Unfortunately, I could not get Hallowings in time for Halloween, and I feel terrible about that. The Halloween is pretty much the exact same thing, but it's a skull. So, like, pulling my hair out. But of course they sold out because it's almost Halloween. Yeah. If you're looking to sponsor, reach out on Meetup and we can talk. Sponsorships are 501c3, so they are tax deductible. Where's the cursor? I don't know how to use computers. That's why I started this group. So, come on.
Is there a page down?
Oh, here it is. Okay, there we go. So, yeah. New members, raise your hands. Who's new here? Who's never been to one of these? Welcome. Thanks for making it out here on a chilly October day. What we like to do is just a quick intro, your name, what you're doing, and something that's completely non-code related. So what you are going to be for Halloween. I'm Faris. I'm a senior backend janitor at Team, and I'm going to be a taco. Tom.
I'm Tom. I'm between gigs right now. I've mostly used R, but I thought since I'm between gigs, I should learn something about Python. And
It's either what you're going to be or your favorite one you've seen, if you don't know yet.
I don't know. I'm in the area of Devon.
Sweet. Awesome. So, and then Tom also used to be a physics teacher, right?
Among other things.
Among other things. So,
Yeah.
Tom sounds like quite the Renaissance man. So that's pretty cool.
Or something.
Yeah, or something. Who else is new? This gentleman.
Dean, I just moved here about a year ago.
From where? If we
Bay Area.
Oh, sweet. Another SFO refugee.
Yeah.
Welcome.
On the side, I'm doing a lot of landscaping, trying to take care of a house, finish up projects before it gets too cold. In terms of technical, I like playing around in Python and Go. Those are my 2 languages that I get joy out of.
Sweet. Do you do landscape work in exchange for Python lessons?
If you can teach me some about Python, sure. Yeah.
No, we'll find you a Python gig. That's what we're about here. So, sweet. Who else is new? Oh, sorry, Halloween costume. What do you want to do? What are you thinking?
Probably just turn off all the lights and not let trick-or-treaters know I'm home.
Sweet. Are you at least going to watch like a spooky movie?
What I would,
Spooky movie?
I don't know, probably, I don't really have the spirit there, I have to say.
No worries. No worries.
It's early.
Oh, why is Dylan raising his hand? He's not new.
You haven't shared these yet, the notes.
I did, but for some reason they're not posting.
I was able to.
I got it.
Yeah.
You did? Is it a comment in the?
It's the first.
It's the first comment in the Meetup itself. However, Dean also had the same issue, and I'm betting that Meetup is having caching problems right now.
Wow.
Because they also used to be owned by WeWork. Anyway, who else is new? This person over here.
My name's Brian. I work for a small software company as a developer.
Awesome.
I have a small child, so I won't be trick-or-treating, so I'll probably dress him up as something.
What are you going to dress him up as? Pumpkin?
I think he's got a fireman's outfit.
Yes. Adorable.
My
That's-
wife's a wildland firefighter, so.
Oh, that's awesome. I think we have a pyrogeographer
Yeah,
here.
that's me.
Yes. Yes.
Yeah.
I like Carrie just like name dropped that, just title dropped that. Oh yeah, I'm a pyrogeographer. Like,
Yeah, he does. It's no big deal.
yeah. Awesome. Who else is new here? In the back.
I'm Nick. I am a machine learning engineer. Halloween. I've been rewatching Mr. Robot.
Yes. Oh, wait, is the new one coming out?
I think it's coming out.
I've seen ads for it.
Yeah, I have two.
But I'll probably be Mr. Robot.
Nice. Aren't we all Mr. Robot?
I mean, throw in a hoodie and put the hood up, we're all Elliotologists, I guess.
Yep. Sweet. I mean, I have anxiety, so I'm like halfway there. Who else is new? This gentleman.
I'm Chad. I'm an economist at a consulting firm here in Salt Lake. I do a lot of data analysis with Python.
Sweet.
I also have a small child, so I'll probably dress him up.
Okay, how are you going to out adorable?
I haven't quite decided. Probably dinosaur.
Dinosaur. I like it.
Dinosaur.
Sweet. Like a carnivorous one, or?
Oh, absolutely.
Yeah, okay. Good. We're on the same page there. Anybody else who's new? Welcome.
I'm Alex. I come from the same consulting firm as Chad, also an economist, done data analytics, use Python, interested in just seeing what happens here. In terms of Halloween, Nightmare Before Christmas, Jack, I've been thinking about it, it'd be fun. So, we'll see
I
if
dig
I
it.
actually do it, probably not.
I mean, it is one of the classier Halloween outfits. Who else? Going once. Going twice. We want to hear what kind of Halloween costumes everybody's. No? All right. Totally fine. And then our next thing that we like to talk about is who's hiring around the valley. Right now, SCORE, if you're looking to volunteer, I know that's not hiring, but if you're looking to volunteer, SCORE is looking for mentors. Mentors would be somebody, if you have business acumen, like you've set up and done all the LLC registration and you want to show somebody else how to do that.
So this is business, not developer.
Yeah, it's more business, business oriented, not really development. Full disclosure, my dad puts this up here because he's like on the chair or on the board for that. So, and they're pretty awesome. Like if you're a client, if you're trying to start a business, they offer that service for free. So that's pretty fun. But yeah, who else is looking? I would prefer that somebody types into this because I'm just gonna look very foolish doing this. Is
I'll do
somebody-
it first.
Thank you, Dylan. Dylan's my rock, everybody. Who else? Anybody know of anybody else hiring in the valley?
Ternary data.
Not WeWork.
Hiring soon.
Ternary data, hopefully soon. It sounds like.
So we're looking for data engineers, people who are good at BI. So
Cloud skills in general.
cloud skills in general, preferably certified in the clouds. I know it's a lot to ask from people, but yeah. So
My company is called VaporSense. They're looking for, it's just without the E at the end. They're looking for a signal processing engineer.
Sweet. Are you guys doing like,
Those aren't
is
tasks.
that like IoT stuff or like particulate matter?
It's like sensor signals. We need a lot of pre-processing to be a little tighter.
Cool. That sounds cool. Anybody else? No people hiring in the Valley. I know Recursion put up their ad on the Hacker News.
Recursion's hiring, Pluralsight,
Pluralsight's hiring.
Overstock's hiring, pretty much every place in Lehigh is hiring. Yeah, there's a lot of places hiring right now.
Yep. If you have a pulse and you can type "Hello World" in Python,
This is actually true.
it's more true than people would care to
You
admit.
just gotta get the brain.
You probably don't need a pulse. You just need to type "Hello World" and you get the job, actually. So.
Actually, it's probably bonus points if you can do it without a pulse.
Because you're no robot. So.
But yeah, lots of people around the Valley hiring for sure. Anybody else? Going once? Going twice? All right, who's looking? Todd. Todd and I hooked up on Sunday, so I'm gonna like not hooked up, okay, but like we went to Chipotle and we like went through each other's resumes, okay. It was an intellectual affair. I'm gonna shut up now and let Todd.
Great idea.
Hi, everybody. I'm Todd. I've been a system administrator for about 20 years. I work here at the U. I'm really interested in transitioning from system administration to development. Solid Python kills. My GitHub is on the page. And I want to get on the costume action. When I was in second grade, my mother hand sewed a Robin costume for me.
Nice.
From the the 60s Batman and Robin. I really loved it. And I have pictures if anybody's interested.
Okay, I'm going to redeem myself and say, in terms of handcraftiness, like it definitely runs in the family because Todd also wrote this awesome TK Inter desktop interface that manages all the Macs at this place.
That's not exactly true.
No, not exactly. What's off with it? It's
A lot
awesome.
of
He
it.
gave a presentation about TK Inter, and like we still, I don't know, it was mind blowing. It was still awesome to see that kind of use for Python for a GUI that wasn't freaking Electron. Anyway, anybody else?
Well, this is probably just my own anxiety, but I went to a resume workshop where they said for age discrimination reasons, don't say more than 10. I mean, only don't say 20 plus.
Interesting. Okay. Good to know. Thank
I
you.
mean, it could be that our heads are full with outdated gunk.
That's true.
So, anyway.
Sounds
I've
interesting.
applied for jobs where I was like a lot older. The oldest person was 30. So, anyway, sorry about that.
Well, if you are seeing signs of age discrimination, there's like a room of data people who could probably help make a case with that because, see, that's what we're here for, okay? Utah Python. We'll help you out with that. So. No, but seriously, if you are seeing stuff like that, please let us know because there are, that's a social project that we can look into as a group. We have that kind of, you're with your people. That's what I'm saying. All right. Anybody else who's looking?
Adam Jackman. I'm facing the other end of age discrimination. I'm not sure if I have enough experience with the job I want to apply for. But I've got about 3 years of professional development experience doing mostly back-end work in Django, looking for data engineering type things. I have a stats background. So I was a statistician turned software developer who'd like to transition to being a data engineer. So if you know of anything, let me know.
Sweet. If you want to meet up at a Chipotle, let me know. We can go through I won't use not hookup, just meetup. No, but seriously, if you want somebody to look at your resume and if you need pointers and stuff, always feel free to reach out to me on the meetup. More than happy to. Awesome. Anybody else who's looking? All right.
See all the New York people, they're like,
That goes without saying. If you see one of us and we're like hanging out, you can feel free to approach any of us, and we're probably open to things. But we have too much fun. I remember last time this happened. Yes. I remember when we were. Anybody remember when we were in Zaniac? Yeah. That was pretty fun. And there was like, oh yeah, there's one more. Thank you. Okay, there's one more person who's looking. Just approach Faris after, and he'll tell you. And it ended up being Faris. So, community news, Hacktoberfest. Thanks for putting that in. Who put that? Did you put that? Thanks, Todd. So Hacktoberfest is an awesome thing that is put on by DigitalOcean, if I'm not mistaken. Right? Yes. And you basically sign up. You say, hey, I'm going to support this open source project, and they do prizes, right? For that?
You get a T-shirt.
Yes.
If you do the 4 PRs, and
Mhm.
usually there's a handful of stickers involved too.
Yes. It's a lot of fun. So all those open source projects that you've been looking at, now is a good time to contribute back. And it doesn't have to be anything huge. I mean, again, my partner, she's more in databases, but she did Chinese language translation for a couple of projects in the Python ecosystem. And like even that kind of contribution, it helps a lot. So that's pretty fun. There are less than 4 months, I think, or 3, holy crap. Basically, if you're still on Python 2 by January 1st, good luck. So I'm just going to keep saying this, and then in January I'll be like, -1. Just start going there. Python 3.8 RC came out today, this morning. Anybody have a chance to install it yet? I started playing with it just for funsies, just because it's always fun to build Python from scratch.
What's new in it?
I didn't see that. I just built it. Okay, I didn't use it.
Assignment
But-
operators.
Yeah, that was it. There was the Walrus.
Yeah.
Yeah. Do you know how to explain that in a way?
So the essence of what it is it lets you do an assignment during something like an if expression. So like if you're saying, if I have another line in my file, you can also then assign that line to then be work with inside of the if statement. So
Right.
it lets you bring some things down that way. I'll do a lot of things where I'll do make an assignment of a variable beforehand. It also lets you lazy do things. So if you're doing a bunch of if else's, so if, elif, 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 you typically, if you've got a complex expression, you would assign that beforehand. So maybe I'll create variable 1, condition 2, condition 3. If you actually jump into condition 1, condition 2 and 3 don't actually have to be computed, right?
Right.
You're doing that computation anyways to save stylistically. And so that makes it so that those don't actually get evaluated because it's walking through.
Very nice. And then I think it's known as the Walrus Operator because is it colon equal sign?
Yeah, it's colon equal sign.
Yeah, it looks like a little walrus. So.
The Python to the Point actually had a decent talk about talking through that and talking through the controversies of Python 3.8.
Fun
We got
stuff.
stepping down.
Yeah. All right. Yeah, that would be a fun one to mess with.
I don't know,
Maybe
is
even-
Windows stepping down?
Yeah.
It's not on this machine.
Is there somebody stepping in, or is it just being taken over by the?
It's taking over by a steering council.
Yeah.
So I think they're going to do elections every year.
No more BDFL.
Yeah, and it's really easy to be a fellow. You literally just make an account. I think if you have, I have to double check that. I might be wrong with that, but it's fairly easy to become a member of the PSF. All right, and if you have a hot talk idea, by the way, these are all kinds of talks that people have asked about. If you want to see one, this is a good spot to put it in.
Dylan's giving a talk on Kafka.
Yeah, I was thinking I'd do it.
Yeah?
I think you should do that.
Sweet. And then somebody added this one, and I still would like somebody to do this. It was machine learning for $15, where it's like how to use the cloud tools for that kind of stuff. Did you face that? I can't remember who.
No, it's not me. What about machine learning for $0.00?
Machine learning for $0.00. Tim, there you go. All right. So, how long was your talk? I probably should have asked that before I started.
I won't go over 40 or so minutes before I ask questions. But I have not timed it, and I have not given it, because I, made it last night.
Yeah. Welcome to Salt Lake City Python. That's about our cadence. In that case, I am going to mirror this screen, and we're going to have some fun in the Python interpreter. And this is more of an open thing where everybody's going to yell at me for not doing stuff right. I'm totally keen. There we go.
Are we using your create interpreter?
Sorry?
Are we using your create interpreter?
No, it's not on this machine, unfortunately. Did that work, or did I break everything? Okay, I broke everything. Is there like recursion happening on the screen right now? Okay. Yeah, I broke everything. Ah. Come on, buddy. Just be nice. Why can't you just be normal?
You left it for a month.
1280723. Here we go. Here we go. Okay, that's a little better. Nope, that's much worse.
Wait a second.
Hey.
Yeah, okay.
Sweet. Nobody gets to see my passcode. I know, right? Everybody see that okay? All right, so what happens when you type in just Python, right? Or IPython. If you just type in Python, you're going to get this interpreter over here, right? So very beginner talk. You're going to see, what version you're running, when it came out. This one's coming off Anaconda, because that's what I'm using to run my Python lately. And yeah, you get a little interpreter over here, and it's fun. But if you really want to get like all the niceties about using a command line, I highly recommend just getting IPython installed. And it's going to be the same Python version, right? The only difference is this is there's some magic in here. I think it's literally called like magic. Yeah. So if you did %magic, you'll see there's a bunch of little additional things that you can explore. But yeah, this is an interpreter. So this is just code. Has anybody ever read Why's Poignant Guide to Ruby? And I know I said the R word in a Python meetup. Nobody. I highly recommend you do, even if you're not into Ruby, because it also has a soundtrack and it's a comic book and it's amazing. And it's basically an artful interpretation of how to teach people how to code. The second track is entitled Get It Through Your Head That Computing is Just Words. Like, just programs are just words. And those are like the lyrics, and it's a lot of fun. It has cartoon foxes and like references to bacon, and it's amazing. But yeah, code is just words, right? And if you're trying to teach this to a beginner, or if you are a beginner, you don't have to get too in-depth with things. You can just open up an interpreter and have some fun. So what we're going to do today is we're going to play with some arrays, some lists, okay? So let's get a list of, I don't know, fruits. So now we have fruits, but what are we going to do? We're going to put some stuff in here. Orange, I don't know, bananas. Yeah. So we got fruits, okay? And how do you know that this is a list, or how do you know what type of object this is in Python? You can always just type. Oops. Now, does somebody know how to, like, how would you go about, never mind. How long is our list of fruits? So there's 3 in there. What if we wanted to add a fruit to it? Well, I forget this command. I don't really forget this command. I use this command all the time. But let's say I forget. There's a couple ways that you can use the interpreter to help you out with this stuff. What's one of them? Anybody know one off the top of your head?
One what?
A way to figure out how to append a fruit.
Add a dot and then click tab for autocomplete.
Dot and then tab. And that's exactly right. If you hit dot and then tab, or if you just start smashing tab in general in a command line, you're going to get some, you'll get the commands that you can put in here. And because everything in Python is essentially an object, you can do stuff like this. So 1 is an object, and I didn't even know that it was all this stuff. Oh, maybe it's not an object. What is it? It's an int. Right? But if you instantiate it into a variable, then you get a bunch of other stuff.
It's still an object.
It's still an object, but it doesn't have the fancy tab completion. So fruit dot, what do we want to do? We wanted to add another fruit to it. Somebody name a fruit that I didn't put in there.
Apple.
Durian.
This is the second time that fruit has popped up today for me.
I was hoping for pineapple, apple pen. That's what I was just.
So there we go. Now we got the durians in there. And now I appended it to fruit. Here's a fun question. What's this? What's the value of fruits going to be? So remember I made a typo, then I reassigned it. And this is a fun question, but if any of you ask this in a tech interview, I will slap you. Like, this is not a tech interview question, okay? This is a gotcha. But yeah, the references are the same. So, because...
You want to show them the IDs?
Yeah. So, can you elaborate on what an ID is IDing?
Well, yeah, it's just pointing at the object in memory.
Right. So, in the memory of this machine, which seems to have a ton of memory, apparently, yeah, they're both pointing to the same space on your machine. It's talking about the same, I set aside some memory, I called it fruit, and I'm going to put this stuff into it. Okay? If you say fruit equals fruits, fruits is just going to point at that. Where's the gotcha from this? What's the best way I could show the gotcha on this? Anyone?
Which gotcha are you talking
So the gotcha would be, sorry?
Didn't you already do that? Do you
Yeah.
flip down append?
Yeah, okay, yeah, that's a good point. So fruits change too, but let's say I actually wanted to now separate it. So let's do another example. So we'll do fruits, and then we'll do tropical fruits equals fruits, right? And let's say I just wanted to add tropical fruits to this. If I actually wanted to make it a new list with a different reference, we'd use what?
Copy?
Copy, yeah. Now, I haven't used copy forever. Is this one built in?
COPY and then open parent. Yeah.
I don't know if it's built in anymore.
No, it's
yet.
copy.
It's fruits.copy.
Oh, well,
Or you can use Reach.com.
this have a
Oh.
copy?
Yeah. Might
I
not
gotta
be.
assign it to something though.
Yep. And let's see what happens when we append something. Rapes. No, not graphs, Faris. Tropical fruits. Ooh.
You can do the ID first.
Yeah, let's do that. ID of fruits. ID of tropical. And they're different.
You're gonna say the difference between deep copy?
Yeah,
That was
what's the
a
difference
shallow.
with deep copy versus shallow?
Deep copy is recursive all the way down. So a shallow copy.
Dicks, right?
Or even
Yeah,
the objects
so-
within that list.
Yeah, so if you had a list inside the list, if you do copy, then you'll get the same list in both places. The external lists are different. The internal list, because it's just a reference, right? That reference to the list inside is shared in both places. Which, I mean, is sort of what you want, but not always what you want. So you
That's
might want decoupling.
awesome. Tim, I did not know that.
Ah.
I now know that. This guy. But yeah, did everybody catch what's going on here? So even though we've made a copy of the list object, the objects inside it still have the same memory reference. And that's super useful when you're doing like really large data processing, because you don't want to make more than one reference for all this stuff, right? So you're not having to worry about it. That's awesome. I honestly just learned that. So
What's called copy by reference is referring to the same pointer.
yes, I think so. It is copy by reference, yeah. Any comp sci people? Oh, fun fact about me, I didn't take comp sci in school. I'm a psych guy, so maybe it explains my angry demeanor. But yeah, so that's that. What are some other fun things that we can do?
Can you do that without the IDs? Can't you do like is? Or is
Yeah, you can say crude space is space topical.
I think an is actually not the ID because it does the hash, and then I forget. It's like a stack of different
Built-in
things.
dot is.
Because you don't have to have the same ID to be is the same. In fact, the strings I would be. The fact that those are strings inside is kind of weird because when you're going to get the IDs, because the Python interpreter likes strings to be the same object because they're immutable. So you could have assigned two different strings. Their references are not linked in any way, but they might have the same ID if you compiled the code. If you just ran Python, then they have the same ID because it returns the strings on the fly. It doesn't do that here, so the same code would have different IDs. Not that that's necessarily relevant.
Tim, you're way under the hood right now.
I saw. Have you guys seen the JavaScript WAP talk? I saw a Python version of that recently, and it focuses primarily around the difference between ID and is, and those like other things. It was really fascinating talk.
Nice. If somebody Googles that talk and pastes it, that would be great. Let's actually go through this list, right? That's like the whole point of a list is to go through it. But before we do it, this was fun. I was asked this at a coding interview, and they were like, "Oh, write something to reverse a list." And I did not. Yeah, I didn't apply there. Who knows the one-liner for this that doesn't use the word reverse?
Well, why not?
Right.
Yeah. Well, why not do the list comprehension for it, though?
They didn't say make a new list. They just said reverse. But what's going on here? Does anybody know? So anytime we're making a reference in here, right, we're going to start with 0, 1. Let's say you wanted to get a range. You can start and then say, I want the rest of it. So 1 is actually the second part. So now we're getting banana, pineapple, durian, grapes. Here's something. Let's say we want to stop after a couple of them. So Dylan and I actually spotted some code like this today. We were playing with pagination in Django REST framework, and we got really deep into the code, and we found out that's pretty much it. Like the entire, all like 3 classes of it were just surrounding for like the outer inner. I know it had all this other fun stuff in it too, but it was kind of fun. That was kind of how he spotted it. Is he was like, oh, there's something that returns this outer inner, and they were assigning it a variable. So if you said start equals 1 and end equals 2, well, that's the wonderful thing about code. I remember years ago when I realized I could do something like this. Or the even more interesting one to me was like, hey, I could put like values in a dictionary. Oh, wait, I can even like look up a key this way too. Wow, I should write a database for like this. And I wrote my own NoSQL database driver. Like it was awesome. It had 1 star on GitHub, and it was super slow. And man, just never use it. please. But it's fun. But that still doesn't answer the question. What's that second colon mean? Step. Yeah. So if we're going to give a range of stuff, we can actually step and say every second object. So you'll see, let's see if I said that right. Let's bring fruits right here. So, is it every second object? Did I completely get that wrong? Yes. So first one, skip one. Second one, skip one. Third one. So if I did 3, orange and green. And you can mix them, of course. So yeah, lists are fun.
What does -1 do?
Ooh, what does -1 do?
What does it do?
What's 1 do? Forget about -1. What's 1 do? What's this going to give me?
The second element.
It's going to give me the same thing.
Oh, that's the
So now
Yeah.
is that a copy?
It's a count. That's a good question.
Is that equivalent to dot copy?
Nope.
Aw, snap.
Yep. This is what we do on Wednesday nights.
So here's a question.
Yes.
So you know how you can do A comma B equals B comma A? Can
Yeah.
you do fruits of 0 comma fruits of 1 equals fruits of 1 comma fruits of 2? To swap 1 and 2 in your list? Will that work?
Like that?
Yeah.
What are we expecting, right? The first two will get
Swap
switched.
orange
Right?
and banana?
Yeah. Yeah.
Hey, it works.
Hey!
Aren't you
That's
glad?
Get out.
Thanks, Dan.
If you think that was the worst joke.
You're not
Just try working with them.
His talk name's Audio Yo.
I tried to think of something clever too. I was going to say like sounding off with Python or the shape of the hiss or something like that, but audio yo is what we decided. What? You're not liking our puns? All right, so what's some other fun we can have? Oh, okay. Let's take a list and add it to another list. What are some ways that we can do that?
Veggies?
Veggies?
Plus.
Plants.
Well, let's make some veggies first.
That's a fruit.
This is just to tick off the pet ants. Also to tick off the pet.
Tomato's technically a fruit.
So we're gonna put it in the fruits?
Knowledge is knowing that a tomato is a vegetable, but wisdom is knowing that you should never put it in a fruit salad. Wait, what? No. Tomato is fruit. Damn it! I'm neither! And I delivered it with such, confidence. What's this guy do? Nothing returned. What's that operation called? See, I'm not a comp sci guy, so I don't know what this is technically called, but is it mutated? Is that the word I'm looking for? Did we mutate fruits?
Modified in place?
Yeah, modified in plates. You're probably way on that. Sweet. So now fruits has been extended. Contaminated.
Although
How
now
do we
tomato
undo
is
the-
in the fruits, so.
Yeah. How do we fix this contamination? What's the opposite of extend? I don't think there is
There
one.
isn't a.
Remove.
Yeah.
You have to
I don't think
remove
you can.
remove
Yeah,
or
I
do it.
think you have to remove them one at a time.
Can I pop a specific item?
Yeah.
Do a list comprehension for it.
I mean, the pop will return and then.
Everybody just wants to see the freaking list comprehension. All right, what's a list comprehension? What's so nice about them?
It's one that Guido likes a lot.
Yeah. Is that the only good thing about them? Like, that's the reason that they decided to go with Java at our company, just because the guy liked it. Okay, what's the actual good use of it?
For loops inside out.
Yes.
You could try, like, if you wanted to get rid of the veggies in there, I'm not sure, I'm pretty sure it works. You did like fruits.pop food for food in veggies.
Yeah, you can do that.
Ooh, I like it. Okay. As a list comprehension, you're thinking?
Yeah.
This guy over here.
Well, if you're doing it as list comprehension, just
Well-
do it for not in the other list, right?
Yeah.
Okay, for people who are like, wait, what are these guys talking about?
So we're going to talk about time it now?
You should probably
Yeah.
explain what a list comprehension is.
Yeah, let's start with the list comprehension. X is, so a list comprehension is basically, it's a way to map onto a list in place. Is that a good way of?
No, I mean, it's
No,
basically
more
the
of a-
operations you do in a for loop, but you can do it in a syntactic sugar way, right, on a list. So all your operations, you can do it in a compact Pythonic sort of way.
Yeah, so let's say
And it can be annoyingly terse as well.
Indeed.
It's also slightly more efficient.
It is slightly more efficient. It's more performant, actually. So,
Let's do. Okay, let's say your boss comes up to you and they're like, I want, everything has to have like a qualifier in here. So they want to put like the letter A in front of everything. Let's say, well, then all you would do is you'd say, here's our X variable right here, and that's going to be our loop variable that we instantiate here in fruits. Now, the other thing that people were talking about is we were trying to pop stuff out, or we're thinking of doing just not in. So you can add a conditional to the tail end of this. So X for X in fruits if X not in veggies, right? Does that look right? I always get these messed up.
Yeah.
There you go. So that's a nice one-liner. Has anybody done like the 12 days of coding or whatever? Yeah. So that's one of my favorite things to look at, because I've solved a couple of them, but I just love seeing somebody will always come up with a Python one-liner that's super terse that you would never ever use in production, unless you were the only dev. And yeah. But yeah, this is a very elegant way to like build another list that doesn't have the stuff in it anymore. And we can actually get even nastier here. So now my fruits are changed again. Now I wonder if the ID changed. Oh, here's a question. What happened to our friend Fruit? At some point kept that. So that's interesting.
So that's what.
You overrode it.
Yeah.
Just then.
What's another fun thing that we should talk about with lists? Let's do a basic for X in fruits. I remember when I was learning Java, oh my goodness, there's like 10 different ways to do this, and all of them suck. So, I mean, that's how easy it should be to print out everything in a list if you wanted to.
you know, like system out.println.
Yeah, well, yeah, and they don't, and everything's an array. We don't talk about it.
Well, also, like, the operations you do on queues is a lot easier in Python, like popping and all that kind of stuff. In Java, there's like a million ways to do those. Probably, actually, literally.
Has anybody worked with set theory? A little bit? That was my favorite part of linguistics, which we studied in our psych classes. But fruits, you can do set fruits, right? So this is now a set. So if I was to do fruits dot append banana, now we got two bananas in there, right? But if I did set fruits because a set can only have one of each object, we can do stuff like that. And because it's a set, let's add a tomato to this. We'll probably wrap it up fairly soon. Fruits. Okay, so fruits set. Oops. It's the end of the day, okay? Give me a break here. I forget all the little stuff that we can do, but we can do an intersection on set of veggies. And what should this say? Tomato! And thus, a tomato is both. And that concludes our talk about the interpreter real quick, because we've got to move on.
Should we do a minute?
Yeah,
for water?
we'll take like a 5-minute water break because we're setting this guy up. But please be back here at 8. We'll say that.
All right. What do you think the chances are? Ooh, an HDMI. Wait a minute.
Do you want to see how this works? This is
I wanna see-
input.
I
It
want to
goes
see
to
if
here.
that,
Look
because
at
that'll
this.
also have.
No, don't do audio through HDMI.
Well, I won't try.
Yeah.
I'm
because
just going to try to play it
No, it
right
will.
now. I am just going
It's
to.
a public university.
God damn it.
If you type Google into Google,
Well, I'm just going to try to play something. Do you want me to? Sorry, is there something that I'm? Woo!
that was loud. I got the audio stuff over here. I can lower the volume.
Well, okay. I mean, I figured I would just do it there. Yeah. Okay.
Yeah, I got you.
All right. Let's try something a little less. I'm gonna cringe-inducing. Sorry. That's just probably how it's gonna have to be. Because otherwise, and I'm not even on that space.
You should mirror your screen. Is my suggestion.
All right. Yeah.
So it looks like you're writing in a notebook.
I
You're gonna be clicking
sort
stuff.
of.
And, yeah, I was
I'm-
mirrored.
Yeah, that is fair.
That's two. Was this the basic research stuff? No, but actually,
I don't know. So I went to law school. I did that for a while. I started. So I did a JDA. So I kind of had some business schooling there. And I started a business with some friends from that. That was we did high efficiency lighting. So I worked in the kind of energy efficiency area for a while. Got some certifications there. So I'd love to use that if I could. It's a pretty new, this kind of people putting mandates for requirements. So kind of no one knows how it's going to play out. Who's the boss of this? Who stamps this? Like an engineer stamps a designed for a bridge, but who stamps the certification that you're complying with this? Like, who's the authority? So I don't know. Interesting.
I worked with, I was a finance guy. Needed certification after I did my cooling tower installations. We had to prove a certain amount of efficiency.
Yeah, I do that. Right now I work with Nexon and KW is another one. Nexon does the schools and KW does, like if you're big enough that you have an account manager. So yeah, I do that, go out with the engineers, they put together a report, a customer does the project, we go back and verify. So yeah. No, I mean, they're always changing. Like right now, they have an incentive specific for rooftop. It's like the big package units you see on top of all our buildings.
Oh,
They're really trying to get people to increase the efficiency of those. But I mean, a lot of what we do is like custom stuff, like scheduling. You know, you haven't looked at that for 10 years, or maybe your clients have changed and you're running it all the time when you need to run it 8 hours a day or whatever. So a lot of that stuff we just go through.
You ready to go?
Yeah.
Right, exactly. So yeah, I mean, there's a lot of automation that could happen.
Pythonistas of Salt Lake City, allow me to introduce you to Tim Anderton. Tim Anderton is that rare combination of kind and genius who you will hopefully run into a person like him at least once in your life, and thankfully you just have. Tim's presented a number of times at our meetup, everything ranging from elliptic curve cryptography. That was you, no?
That was definitely,
No, that was the other guy.
yeah.
Okay, never mind. He's okay. No, Tim presented this thing on Gödel Escher Bach and using what you did a projector.
I was like, okay, TensorFlow or 3D printing. What should I do my talk on?
Oh, and you did both.
I use TensorFlow to machine learn something I can 3D print. I've never done either before. I'm sure it will go fine.
And it did.
It actually went fine. That wasn't supposed to happen.
Like usually there's like dramatic conclusion. No, it went perfect.
It was fine. It was.
So please give Tim a warm welcome again.
Thank you very much. So I'm going to do a sort of silly talk within my talk, almost. A micro talk, just on. First of all, so I use Nicola, which is a blogging platform. It's for Nikola Tesla, and I do all my blogging in Jupyter Notebooks because it's really easy and simple. And then I push it off, and I get these HTMLs. But I really like doing all my things in notebooks, so I don't want this. I will let you live, just in case you have something to do with things being correctly set up. But if you ever, so this is my website up here, and if you ever see something that I've done on my blog that you think is cool, then you will always be able to do the following thing, and just say, that was really cool, I want some of that. So how about I get to play with that notebook? Also true, in this case, and you just have to do, say, that's an IPython notebook.ipynb, grab me that guy, and then you can launch it, I think, and then you've got same notebook to play around with. In this case, the only reason I'm talking about this at all is because I don't think people even know that, or most people don't know, that Jupyter Notebooks have the ability to be converted to slides via NB-convert. And I really, really like that functionality. And I had been using Jupyter Notebooks for some ungodly amount of time before I even realized that that was the case. Although, actually, to be fair, it wasn't that old of a capability at the time that I discovered it. So, but so for this presentation, I made it in a notebook, and you go up here, and you couldn't see any of this. I pushed it off. This is my blog, and you can't see. Here are these note blocks, all this text, because I'm going to be saying this crud, so I don't want it junking up my presentation. So over here in my notebook, I have told it that this is going to be a slideshow. And so I say, hey, give me the slideshow toolbar. And then you do these. You label on the side what you want to have happen when you press next, or whether you want to show it or not. And then if you want to see that slideshow, you can just serve it, which I happen to have already done, and I'm just going to grab that. I don't want that. Spoilers. All right, so I don't know if it's worth full screening or not. I'm just going to let it be. Because I'm going to switch around. So, like I said earlier, I was asked to give the talk yesterday at 4 and started writing it at 9. So I have not gone through this.
That's my bad, by the way.
Well, actually, I was asked at 2 and didn't see it until 4.
Credit where credit is due.
I mean, that's a very different thing. So I love working with audio data in Python, Jupyter Notebooks, that sort of stuff. I mean, I love playing with Python. Python is my go-to toy, and one of my favorite toys in the set of Python toys is definitely working with audio data in like Jupyter Notebooks and using them in like fun little my own personal, fully customizable synthesizer. Right? It's my audio, if you will. Okay.
It's still not the worst pun we've heard.
And
an orangey glad of that.
You're still here.
And so something interesting about audio data is I feel like that that unlike most or other kinds of data that you might be interacting with, or rather more typical kinds of data, are numbers, images maybe, or text, something like that data. And I feel like that if I see a picture, I understand that picture. If I see a number, some text, I can read it, I can rewrite it, I can sketch the picture. I understand what's going on, but I always have this sort of sense of like of this mystic, exotic relationship with sound data, where no matter how many times I hear it, I can't reproduce it. I can't hum it perfectly. There's something about the structure of the data that I have never really, with the exception of very simple sounds like sine waves or whatnot. Maybe I understand those, but raw audio data, is this weird, crazy thing that I always have fun messing with, no matter what. And audio data in general, just like saying, okay, audio data, what can you do? That's just too big of a thing to shove into what should be a relatively short talk. So I need something to organize, some organizing principle for the talk. And I like stories that are like pursuit of some lofty goal, some epic journey, right? So we need some lofty goal. And But I mean, it's a short talk, so I shouldn't get I shouldn't overreach. And of course, if you know me, you know that I have no problems being overambitious. And so I just pulled back my scope, and I picked what I hope we can do. Maybe we will be able to pull it off. I want to write some Python code that makes a random sound. Okay. And you say, that's going to take like what? I guess it's going to take like 30 seconds, and then we'll all be gone. No. It took about a minute and 30 seconds. I timed myself. So we've got some time. And actually, I want to say that like this right here is absolutely astounding to me personally. The fact that I can just have my Jupyter Notebook. I didn't do anything to get this capability. This is built in to Jupyter Notebooks, and you all, if you have a working Jupyter Notebook environment, most likely also have this capability. And I think the ability to here I'm sampling from some unit normal distribution, and I dump it into an audio object, and it shows up in my browser, and let's hear the truly random sound. Yeah, so the fact that I could do that actually is, somewhat a testament to the power and flexibility of the Python and IPython and Jupyter Notebook ecosystem. It's also just, the power of browsers, because they're just shoving this into an HTML5 container, and that's really all it is, actually, if you look under the hood. But okay, so that was a random sound. That was one possible sound out of the space of all possible sounds, right? So I've heard that sound before, but I want more. Like, there's a lot of sounds. There's a lot of diversity of this sound universe out there. So I'm going to dip back in to this audio universe, and I'm going to grab an entirely different sound. And what could this be? Like maybe a tune? Like I think that was the same sound. I probably set my seeds wrong. I mean, what's a random sound? I mean, if I'm writing a function that I say it gives you a random response, totally random response every time, and you run it, and it gives you the same damn thing every time you run it, that's not a random function, right? And I couldn't tell the difference between those two if you paid me. Like, you can give me hours to study. You can play both sounds hundreds of times. You can let me take notes. I will never be able to tell you which of those two sounds is which, even though they have completely different sound intensities as a function of time, right? So that's actually not what I want, because I want something. I want to reach into the audio universe, and I want to pluck out something that sort of covers the set of all possible sounds. No matter how many times I run that function, I'm going to get static. Right? That's what people would call that noise. That's just one noise that I happen to get a lot of different variations of. But in terms of my coverage of the universe of possible human sounds, I've hit exactly 1 point so far. So I have not achieved this goal. And in fact, I would say that this is, like, I was a little tongue-in-cheek earlier when I was like, what could I pick? Never get overambitious. But I've been thinking about this sound, this idea of this, this universe of sound for years. And in some ways, if you think about it, synthesizers are one kind of way to turn the space of sounds, or some corner of it, some tiny corner or maybe larger corner of the universe of sound, into something that you can understand. You can tweak some knobs, and you can change the length of the chirp, and you can make some extra frequencies. You can parameterize, you can understand a tiny corner of the sound universe. But I want, in this sort of grand goal, to draw a random sound. I want to draw any sound that you could hear as a human. I want to be able to sort of get them sort of evenly, right? I don't want every time I grab a sound for it to be just white noise or a pure tone. I want to sort of cover the space as well as I can. And I'd like to be able to be not much too likely to get any one thing than any other, not too likely to get music versus noise versus whatever. I think that that's, sort of impossible. But like I was saying about synthesizers, there's some tiny corner of the audio universe that gets mapped out and understood. And then you can tweak the parameters of that synthesizer. And you can say, well, if I sort of put some uniform distribution over the synthesizer's parameters, then I can, sort of sample the perceptual space possible, by this, given to me by those set of knobs. And so here's this sort of grand goal, one step back. What if you put, say, silence at the origin of some abstract high-dimensional sound universe, and you put everything that we can just barely perceive as different from silence at radius 1. And in fact, anything that's just barely perceptibly different by your average human from anything else in terms of that sound is distance 1 from that. I don't know that that's a well-defined space. I don't know that that's a thing. But as a concept, that's where I would love to go. I would love to be able to think about this space, understand it, and draw sounds from it sort of uniformly. Because then if I can just pick any place within that space, then that's what I've done. I've got a random sound that a human could hear uniformly over the space of possible human sound perception. So that would be really, really cool. We're not going to make it. But we couldn't take a patch, right? And here's a post. I saw this a couple of years ago, or I guess couldn't have been that many years ago, but but I saw this post of someone. Huh?
That was 2.5 years ago.
Yeah, well, feels longer. Oh man. But so one of the things that you might want to do when you want to reach into this high-dimensional complex space you don't understand, you just want to see what the structure of that space is. A standard tool is principal component analysis, right? And this man grabbed a data set of 100,000, 50,000, whatever it is, I forget, loops of techno music, and then he says, okay, do PCA and listen to the results. What's that sound like? And I saw this data set and I said, man, that's super cool. I think I can improve it just a little bit, but I'm going to first replicate what he did. And I think these are actually loaded, so I'm just going to use these. But so here's a couple example techno loops. I don't know if that's, yeah. Tell me if that's way too loud. What do you need? Okay. Okay. So there's a lot of variation. And none of those really sounded particularly like any of the others, right? And I'm going to see how well that principal component expansion has understood these noises. And I'm just going to do it by saying, all right, PCA, you get 10, wait, how many? No, you get 500? You get 500 numbers to represent those loops. And a little bit of a change in one of these directions is changing the waveform in a particular way that I understand. Right? It's the principal vectors is that are coming out of this thing. And so these are supposed to describe the structure of this space. And if they've captured the structure of the sound well, then hopefully just 500 of the couple thousand numbers that intensities, these summaries of those sound intensities should sound good, right? So let's see what they actually sound like. So each of those little bumps is actually switching to a completely different techno loop. And when we listened to them before, they were completely distinct, right? We could hear exactly what the distinct identity of each of those. We would never confuse them for each other, right? Because they sounded so different. So I'm going to say that actually PCA didn't really do a good job. PCA was totally unable to understand at a fundamental level the structure of our data. And why is that the case? Well, so the thing about sound, or one of the first things that you'll learn about sound if you start digging in, is that sound is waves, right? It's oscillatory sort of signals that go up and down and change over time, right? And so the way to deal with oscillatory data in general, you got some wiggles, right? And you want to break them up into atoms that you understand. And the atoms that are typically used to represent things that oscillate in time are sine waves, right? There are sort of the way that we can understand what it means to have a particular frequency. Sort of the thing that is most purely represented by the concept of having a frequency of, say, 20 hertz is a sine wave with that particular frequency, right? And anything else is sort of a mixture of other frequencies in a certain sense. And the Fourier transform lets us do that decomposition. Take some wiggly thing in time and sort of turn it and decompose it into some set of strengths of a couple of sine waves. And cool thing about the Fourier transform is that it always works. There's always such a representation. Right? You can always do this trick and do this decomposition. And then we could take our sounds and we could understand sounds in the Fourier domain, which is this frequency domain, and then maybe we'd do a better job, right? So I want to take a moment to, no, whatever, that's fine. I want to take a moment to actually talk about human hearing a little bit more in depth, which is we don't just hear frequencies. We hear fundamentally frequencies, not intensities, right? Because if we heard intensities, we would have been able to tell the difference between those two bits of white noise. But we don't hear every frequency equally. We hear low frequencies with much more precision than we hear high frequencies. And most of the information in sound is in the higher frequencies, and we just don't have perceptual access to it. We bin up frequencies in sort of log-scaled bins so that we can tell about 1/20th of an octave, which is a factor of 2 in frequency. And if you have perfect pitch, you can do a lot better actually. But most people don't have perfect pitch. And these are sort of the typical numbers for a human who is, not too special. A lot of people can hear over 20 kilohertz, and a lot of people can hear under 20 hertz. But the typical human audio range and the bulk of the sounds that we listen to are somewhere in that range. And they're sort of 200 bins. So if you divide this up into octaves, that's how many factors of 2 are there between 20 and 20,000. That's about 10? 10. That's about 10, because the ratio is 1,000, and 2 to the 10 is 1024, right? And so there's about 10 octaves there and we can bin them up into 1/20th of a factor of 2 steps. So we can hear or differentiate about 200 steps in frequency. And actually, interestingly, we can't hear volume nearly so fine. So you can hear up to 160 decibels, say, but you'll start losing your hearing at that point. And 120 decibels is loud but painful noise. And if you want sustained volumes, say 70 decibels. And 1 decibel is the softest noise that a human can distinguish from silence. And I gotta say, so a decibel is 10 divisions on a factor of 10. That's what it is. And so this is pretty crazy. We can hear over 12 orders of magnitude in audio power. That is so crazy. Because it actually means that when it's very quiet, our ears are so sensitive to noise that we can actually start to pick up thermal fluctuations as sound, which is totally mind-blowing. We got good hardware. And interesting fact, if you hear a sound and its duration is less than about 0.1 seconds, it'll all start to sound like clicks. You sort of lose definition in frequency space. And you can hear when it happens, but you can't hear what its tone is, even if its tone is very well defined. Because a 20 kilohertz tone takes a lot less long than 0.1 seconds to do a few hundred oscillations, right? And so most of the frequency space that we can hear actually is capable of being well defined in much shorter timescales than 0.1 seconds. But our hardware is just not built for it. So that means that frequency space at any rate is about 200 dimensional. And I'm going to say, okay, so let's understand the sound universe, right? We've built some understanding of the universe of sound. We know what it is. It's built up of these frequencies. So instead of starting with intensities, let's start with frequencies. Let's space them out logarithmically so that it matches our perceptual understanding of sound. And then let's randomly sample from this 200-dimensional space of sounds and see what that sounds like. Maybe that's a random sound. That's sort of an atomic sound. Kind of it should cover the space of what it's possible for us to hear as humans, right? And that should be a lot more interesting. So here is the most. Is that true? I won't say that. Never mind. So what I did was I said, okay, we hear volume logarithmically, we hear frequency logarithmically. I'm going to space out some frequencies in the log. So linear spacing between the log of the minimum frequency and the log of the max, and then put them through the exponential. Now I've got log spaced frequencies, right? So they double every once in a while. After every few, I don't know what the number is, and then after the same number, the frequencies double again. And then I'm also going to pick my volumes logarithmically, and I'm going to go ahead and just pick them uniformly in the log. And then I'm going to interpolate, because I like fast Fourier transforms, because the Fourier transform is this complex mathematical thing. And it's a sort of this broad concept. But if you're a coder, you use the fast Fourier transform. The fast Fourier transform maps you from it's fast, right?
You don't want that.
I have never written slow Tor.
Go use that one. The one takeaway.
and so the fast Fourier transform takes all of the frequencies linearly spaced. And so I have to interpolate those log spaced frequencies onto a linear frequency scale, and I have to do something with some complex numbers. What is going on? I don't know. And I take the inverse Fourier transform and I get a set of frequencies. Okay, I get a random mixture of volumes and tones that sort of tries to cover the human perceptual space. There was something else. Oh well, doesn't matter.
Return locals?
Yeah, what's...
I'm sorry, that's lazy. That's just, I just want all that crap. I wrote this code, I do this all the time.
You might as well do globals.update.
No, this is great, man. This is like legit useful, especially for working in notebooks, but other stuff too, because so this is a pro tip. I'm behind this because maybe not in production, but in workflow this is great.
Within a function, that's well defined.
Yeah, no, I mean that is true. It's only there.
That's the
I just don't use it.
so it's just returning everything from the
Yeah, it's just I want access. I might want to know what my frequencies were, what random numbers I generated. I want to know these internals, and I don't want to return them one at a time, and I don't want to write out a dictionary that maps the names that I already have to the names that I'm going to want to access it as. So I just say return locals, which is return all the things I assigned inside this function, which I saw it a while ago, and I was like, that's gross. And then I thought about it, and I was like, that's genius.
It's still super lazy.
Yeah, it returns a
It is super lazy. Isn't it great?
Yeah. So there's two keywords.
If I catch this in a PR, it's a resume generating event. Just saying.
but it's really
It's helpful for this. This is
There's
I mean,
globals
especially
and
for
locals.
yeah. So all the local variables.
And
are
if you
being-
call it like that, it returns a dictionary of all of the variables in your namespace.
Yep. Yep.
'Cause
I mean, but there's
namespaces are just
nothing.
dictionaries.
But never mind. I don't use it. I don't actually use it in any production code that I would. And I'm not sure that I'm willing to argue about whether or not that's a good idea.
Tim, it's very
But oh yeah, sorry. That totally blanked my flow. I am all in Google.
So now you're calling it.
So let's grab that thing and let's look at it.
Yeah.
First understand it, and then we'll listen to it. Right? So I grab that thing. What the hell is it? Well, it's some set of frequencies, and I picked a few random frequencies that get to have non-zero, non-zero volumes, and then I run it through the Fourier transform to turn those frequencies into intensity, so I can make my speakers do it. Right? And then, fun fact, what would happen if I picked, lit the magnitudes of each frequency be sampled uniformly? What do you think what would happen? What sound might I get back? And it is important, one sort of thing that I skipped over, that's what I skipped over here, was I'm picking random phases, which is random shifts for each sine wave. So this is not necessarily a fact that is well known, but it's a fun fact that it's actually, we've already heard it. That's white noise. That's static, more or less. It would sound just like static to us. It depends on how finely you're sampling your frequencies. And in the log, it would sound a little bit more garbagey. But if you randomly and uniformly sample your frequencies and pick random magnitudes for each, well, the sort of stationary state of that distribution is a complete mixture, a complete jumble. Sounds that just doesn't know about where it is or what's going on. It's just random white noise. So let's listen to that first sound, see if it's a better cover, if we've really managed to pick a random sound. See, so this was an atomic sound. I picked 1/10 of a second long because that's like where we stop really being able to hear frequency, right? And actually, that was kind of good, but I can't hear the structure that way, right? So I'm going to just draw a longer sound. I'm going to do 2 seconds and see if that's anything more understandable, right?
Perfect for Halloween.
That's not bad. Actually, and it sounded a little different than the other one. If I keep drawing these samples, if I keep reaching into the audio universe and plucking something out, what's it sound like? Yeah. Now we're getting back to that chapter. Those all kind of sounded the same to me. Like they were distinct. I can tell them from each other, but I don't think we've made it very far in our quest, right? So because if I were to listen to that for a long time, I'd be like, God, stop it already. They all have that same sort of quality, like, right? You can all hear this sort of nasal sound. I'm never going to get anything that sounds, like a clear tone, for example. That's part of my audio universe. That's something that I have special hardware to understand and a lot of experience with. The way that my perceptual map of sound, and all of your perceptual maps of sound is built, is not really based just on frequency. There's all sorts of other junk in there that makes it fun and interesting. We have special hardware for hearing changes in frequency as a function of time. We're better at that in some ways than we are at picking exact tones, right? And we have extra special hardware in our brains for understanding the human voice, which, obviously. Obviously we would, right? And that makes this problem, insanely problematic. How could we possibly ever be able to cover the full set of perceptual space and sample from it in a uniform way? Well, actually, why don't we go back to the techno and think about it a little bit longer. So this is still just a sample. This is one tiny corner of the audio universe, 50,000 techno loops. But that describes that corner of the audio universe. And there's no reason in principle why, if we couldn't learn to understand that corner of the audio universe, we couldn't just nom lots of extra audio data, all the crap that we record and generate and listen to in our spare time. That stuff is what makes our brains hear, right? Is what we are designed to hear, what we like to hear. That's the audio universe. I want to learn to sample from that. So this couple of years ago, I saw this PCA post, and I said, that's never going to work. Phase cancellation is going to murder you. Okay, what the hell did I just say? That's all those random shifts. If you got a bunch of sounds, and I unfortunately killed this, but if you've got a bunch of sounds, so say you'd got this audio clip, and you break it down into its frequency components, you get this guy. Okay, what's that nonsense? Well, that's real and imaginary parts because there's two parts. There's a phase, which is the shift of those sine waves, which is how the amplitude, how the volume of that sine wave is distributed between its real and imaginary parts. And if you take a minute to think about things sort of deeply, here's that sound broken out into its frequencies. And then there's a couple of different phases, which is to say there's different components. So each vertical line in this plot corresponds to a particular exact tone. And out here we can't really start distinguishing the neighboring tones from each other necessarily, but this is what the computer hears. And or how it represents our noises. Right. And so if you take a sine wave that has this exact frequency, this guy, right? These peaks, and you add them together, you'll get a representation of your waveform, of your intensity of sound pressure in time. That's actually a pretty good. That's actually a pretty good representation of the whole waveform. That thing is dominated by a few frequencies, and that's what those peaks in that other the Fourier plot are telling us. If you try to reconstruct the data and you just say phase information is shifts in time, I can't hear shifts in time. I can't hear exact frequencies. I can only hear relative frequencies. So phase information, temporal information doesn't matter. You get this garbage. And actually, that's because of weirdness about the Fourier transform, that it's defined so that these two end pieces are close to each other. So this is 0, and this is -1 in time. And actually, what we really wanted, right, was we wanted, oh my God. We really wanted to pick a phase at the center, put a little bump, and we get a little chirp. Why is that happening? It's because all these oscillations are mismatched. We force them to line up at the center of our sound, but then they start oscillating with different frequencies. They get out of phase with each other and they cancel out. So we need a way to, PCA will only ever pick out special directions in our space for us if there are variations that tend to happen in particular directions. If we're constantly changing things up by shifting these sine waves around, then no point in time, no single point in time is going to tend to have a high sound intensity versus a low sound intensity. It's all going to be the same. But we can sort of cheat, and we can say, what if we just forced that upon our data? And we say, pick a random set of little shifts and distort our audio so that we know that it tends to be high at a particular point or low at a particular point. And we do this over a little micro, sort of very zoomed in a very zoomed in way to our data. And we look at how much of the structure, how much of the structure of our data looks like noise and how much of it looks like understandable, pick-upable structure. And once we've done this little magic trick, it gets much better. And if we listen to the same reconstructions, given the same amount of freedom, then we get... Whoa. Isn't that like beautiful, high-quality audio? I mean, I slaved over these reconstructions for probably longer than I should have. And so I gotta say that I think you have to conclude that this grand lofty goal, well, this particular quest has ended in failure. But actually, failure can be a lot of fun. And I think I hope I've convinced you that you should join me and come have some fun playing with audio data and being like, what the hell is going on here? Because if you've never done it before, I guarantee you will have that reaction when the first several times you try to use a Fourier transform of any sort.
And you'll look at that one graph that shows the two directions.
And be like, okay. All right, thank you very much. I apparently completely lied about the 40 minutes, but...
Worth every second. That was one of the best presentations I've seen about an esoteric Python thing. That's awesome. And it's not even that esoteric anymore, right? We were just talking.
It's like a couple of lines of code.
Yeah, it's 2 lines of code.
Yeah.
Took you 1 minute and 36 seconds.
It took me 1 minute and 36 seconds. And it's relatively simple. Even with Stack Overflow in the process, it's not 10 minutes.
Okay, Tim, so I missed the gap. I missed the jump between your atomic sounds
Yep.
and the way doing your phases. What are we going for there? Because you said tone, it was the tone piece that we're looking for.
Yeah, so what would have happened, I picked a random distribution of tones, and then I said, phases are hard, I'm not going to talk about them yet. And then I'll try to have a phase piece later. And I think I kind of succeeded, but that's a complex story. It's a really complex story. So it's mostly swept under the rug. But if you don't know any better, your phases, so if you pick, you'd say, I don't know, the tones are the important thing. That's what's dictating what this sounds like. Phase information, is random shifts of those sine waves. Random shifts of those sine waves, I can't hear. That's like what? A difference of 0.0001 seconds in the case of most of the frequencies. So it shouldn't matter what I pick. It should sound the same. What if you pick all zeros? They all line up at one point, and then they all cancel each other. They add up, and they conspire to sound like a chirp, right? And so you can't quite do that. But you can get away with just saying, I don't understand phases. Phases are a number that is randomly distributed between -pi and pi. And that's it. That's the end of the story. And you can often actually get away with that. It gives you degraded audio quality in some cases, but you can still play. You know?
Is there a compression that does that?
An impression?
Compression, like audio compression.
Well, yeah. So what you actually need to do, which I guess this is important, and if you read this post, it will tell you this. You cannot get away with doing the Fourier transform. If you try, it sounds like garbage, because that's a global over 2 seconds sort of time span, and your phase information gets more and more and more important the longer your temporal domain, the duration of your sound that you're running through the transform. So you never want to run a sound clip longer than, say, 1/10 of a second or something like that through a Fourier transform. So you chunk it up into 1/10 of a second bits that overlap and do the Fourier transform on the bits. And that's the short time Fourier transform. And that's the only way to deal with your audio, really, because it gives you a mixture of understanding when things happened and what their frequencies are. And it's not perfect, but it's by far the best. Well, I actually really like wavelets. Don't use wavelets.
All right. Thanks again, Tim. All right. So we have 3 raffle prizes. Let's get through these quickly. What is the number that we got to? Anybody?
24.
24. Who's higher than 24? If you don't know what your number is, now's a good time to figure that out. If you don't have a name tag or number, you should let me know, like now. You're 25, 26. Anybody else? 27. All right. And, oh yeah, this is what I get to look at when we're streaming. I don't want to do that. Okay. Import random. Oh wait, number of Pythonistas. What did we decide? 27? Okay, I'm number 0, so it doesn't matter. Random.randint 0 and number of Pythonistas. This is my code review. Anybody? Good? Good to merge? There's no unit test. How do you unit test random? You seed it. 5! There you go. Which prize did you want? CircuitPython. Sweet. And your second prize is you get to hit enter and draw the next thing.
Fantastic.
11.
Yay! There we are. Thank you.
And I'm going to take your second prize for you, if that's okay. That's me. 25. Congrats. All right, and our next meetup I think is on the 5th or 6th. I posted them up. The presenter for today's meetup, they rebooked to that one, so that one's going to be. It was a statistics. It was linear regression on what? I can't remember. It's pretty cool, but I posted it. Details. Yeah, that was it. Energy usage and trying to figure out how to reduce energy usage using machine learning. So that was kind of a cool project that a couple students at the U worked on. They'll be presenting, and that'll be our next talk. And then we'll have one more in December, and then the year's over. Can you believe it? But yeah, so I'll see you all in a month. Thanks for coming. Please drive safely, and make sure to pick up around you. And yeah, thanks again, Pythonistas. Have a good day. Have a good month.
Space of all techno.
Yeah, we should play some techno, like just to play everybody out.
I'm in. So this is random techno.
Random
I didn't
techno.
get it to it, but I trained a Gaussian mixture model and sampled from it. So this is random samples from the space of all possible techno. Not very good.
Play us out. Yeah.